Hi everyone. In this video we are going to solve the problem which is middle element of the linked list. Let's see what is the problem statement. So given a linked list of integers, we need to return the middle element of the linked list. And it is also given note that if there are even number of nodes in the list, that means there are two middle nodes exist, right? So this case we have to return the second middle node. So what is the input? So linked list is always represented using its head node, right? So head node of the linked list is given and the output will be middle element of the linked list. So let's try to understand the problem by using these examples. So the first example is this only, right? So in this case we are having total 7 nodes in the linked list. So this means 17 is going to be the middle node of the linked list, which is our answer. Now let's see second example. So in second example, we are having total 8 nodes in the linked list, right? So this means we are going to have two middle nodes which are 17 and 21. So here note is given that when we have this kind of situation where we are having even number of nodes, then this particular time we need to return the second middle node. So this case it is going to be 21. So 21 is going to be our answer. Let's take input as this. In this case n is odd. So when we are having n elements in the linked list, when we are having n nodes in the linked list, obviously n by 2th element is going to be our middle element of the linked list when n is odd. So if n is even, already in the note itself it is given return the n by 2 plus 1th element. So this case we have to know what is the n, right? It is given that only head node of the linked list is given. We don't know what is the size of the linked list. So here n is actually unknown. So we have to find out n means we just iterate through the linked list and we find it how many elements are present in the linked list. So for this what we will do? We start a current pointer at head node. So this is the current pointer. This is the head node of the linked list. So we initialize current node at head node of the linked list and we start traversing the linked list. So if current is not null, that means we have one element in the array. So initially current will point at head and n will be initialized to 0. So when current is not null, we simply increment to 1, which is plus 1. And then we move our current node further. So current is at this point. Again, current is not null. So we increment n by 1 and we move current to further. And again, if current is not null, we increment it and we move further. Again, we increment it and we move further. Again, increment it and move further. Again, increment it and move further. Then move further, which is actually points to null, right? Reached end of the linked list. So this is going to be our n. So how many elements are in the list? Total 7. So once we find the size of the linked list, when n is odd, we have to traverse the list until we reach it n by 2 element, right? Until current pointer reaches to n by 2. If n is even, then same thing, instead of n by 2, current reaches at n by 2 plus 1 position. So this is usually brute force solution, right? So given a linked list, we are finding the size of the linked list and in the second traversal we are going to find it using n by 2 or n by 2 plus 1 position element. This one, what is the time complexity? So this case, first case we are iterating 1 times, right? So order of n, and second time either we are iterating n by 2 or n by 2 plus 1 times, right? Until we reach n by 2 or n by 2 plus 1. So which is, assume order of n by 2. So overall it is order of n only, but here we are doing 2 traversals. So can we improve it? So can we do it something better than this? So to get idea on better approach, let's take a real case example. For example, we are having 2 points. Starting point is at A and terminal point is at B. In between, we are having some stations. There are two persons, P1 and P2. And the goal of this race is one has to win, right? So who will win means whoever reaches the point B first, that person is going to win the race. So here P1 and P2 speeds are different. Let's assume that P1 speed is double the P2 speed. So P1 speed equal to P2 speed are 2. So they both start at same time at starting point which is at A, and what is the distance covered if this is going to be the case? The distance covered is, for example, if P1 reaches 1 meter long, this means P2 is going to reach half meter long. If P1 reaches 2 meter long, P2 reaches 1 meter long. So like this, if P1 reaches n meter long, then P2 is going to reach n by 2 meter long. Let's assume the distance from A to B is n. So that means if P1 is reaching B is nothing but P2 will be at n by 2 position. So if you notice it, this is what we have to do, right, to get the middle element of the linked list. So if you look at it, these two problems are exactly one and the same. Here we are having n different stations. Here we are having n elements in the linked list. Now let's see how we are going to solve using this technique. So here we have two persons in the race. So similar way, we will take 2 pointers. Instead of 1 pointer, we will take 2 pointers and we traverse the linked list in the similar fashion whatever we have discussed here. So let's take 2 pointers. One is fast pointer, another one is slow pointer. So initially both will point at head node of the linked list. So here fast pointer is P1 and slow pointer is P2 because P1 speed is double the P2 speed. If P1 is at this position is nothing but P2 will be at this position. And again P2 is moving forward means double the speed means P2 fast pointer at this position means slow pointer will be at this position. Then again moving ahead, fast pointer is at this position which is end of the linked list means slow pointer will be at this position. So already fast pointer which is P1 reaches the end of the linked list. Terminal point has been reached. This is tail or end of the linked list means by this time P2 reached this element. So if you notice it, this is exactly middle element of the linked list. Let's see if you are having even number of elements in the linked list, how the same approach works. Initially both fast and slow pointers will be at head node of the linked list. Now fast pointer is at this position means slow pointer will be at one node. Next fast pointer reaches this position is nothing but slow will be at this point. Then fast pointer is at this position means slow will be at this point. Next fast has to move 2 nodes. This is first node and then it is crossing the linked list which means it is reaching null node. So this case slow will be at this node. So what we have seen, if n is odd then we are going to get n by 2 as the middle node. If n is even, there are 2 middle nodes. That case we have to written second middle node of the linked list which is n by 2 plus 1. So this case we have achieved already and this case let's see. So here there are even number of elements means these two are the middle nodes of the linked list, right? This case we have to return the second node which is this one. So slow pointed at the same node when we reached end of the linked list using the same technique. So let's write algorithm for this. So here head node of the linked list is given. So first we have to initialize fast and slow pointers at head node of the linked list. So next step, to traverse out the linked list by stepping fast pointer 2 nodes and slow pointer 1 node at a time. This process continues until fast pointer reaches last node or crosses the last node of the linked list. Step 2, until we reach end of the linked list. So here either fast reaches tail of the list or fast reaches null, right? We are crossing last node of the linked list. Either in this case we have to stop the process and we have to return slow node data. Let's see time complex. If you notice it, here also we are traversing the linked list, but we are just traversing the linked list only once. By using 2 pointers we are achieving. So it is order of n. Even the brute force approach also it is order of n, but in case of brute force we have traversed linked list 2 times. Here only in one traversal we found it. So this is single traversal. So this approach is also known as 2-pointer technique or Hare-Tortoise technique, where usually tortoise speed is lesser than the hare speed. So this technique is mostly give some efficiency over the brute force approach. In this case we have seen in single we are going to reduce this completely in case of using 2-pointer technique. I hope the algorithm is also clear to you. Let's write Java code for this. Here I have already created a class with name middle of the linked list. So before finding the middle element of the linked list, first we need to give linked list by using its head node, right? So for example, this is the linked list. So we need to provide head node of the linked list, which is used to represent this particular linked list. So for this first we have to create the linked list, right? So for that I have already added helper methods which are already discussed in another video, which is implementing the linked list. So the video link I will provide in the description. So in higher level, let's see what all things I have added here. So first thing is we need to have the node class, right? So every element in the linked list is represented using node. This every node is holding the value integer and next node of the linked list. So here suppose for example if we take this first node value 7 and next 3 is pointing to the next node of the linked list, which is 3. Here I have created a helper method which will take array of integers and create linked list for us. So I have added one more helper method to print what is the data inside the linked list. So this is the driver method which I have created, which will take array of integers. So this is the input I have given as array of integers and it will give head node of the linked list. So this head is going to be the input for the method, which is we have to find out middle element of the linked list. Let's run this method to see how exactly the linked list has been created. So first I have given total 7 nodes in the linked list, and this is the linked list which we have seen in the during our explanation. And second linked list is the one which is having total 8 nodes in the linked list. Now let's write method which will return the middle element of the linked list. The method signature will be public and we are going to return the value of the middle node, right? So int get middle and the input will be head node of the linked list. So here first we have taken 2 pointers. One is fast pointer and another one is slow pointer. So initialize 2 pointer list node fast equal to both will point to the head of the linked list. Now we have to traverse the linked list by stepping fast pointer 2 nodes at a time and slow pointer 1 node at a time, right? While let's fill the condition. For now I'm just adding while true. We have to step fast pointer 2 nodes at a time, means fast will become fast equal to fast dot next and slow pointer will be 1 node at a time, means slow is going to be slow dot next. So this means what is the condition we have to stop it? If fast not equal to null, And fast dot next we are moving means both fast not equal to null, and fast dot next not next we are doing means fast dot next not equal to null. Then finally we are going to return slow dot val. Here one more thing we have to check, base condition, if head of the linked list is null. So if head equal to null, simply return -1, which is like invalid value or something, or else we can throw some null pointer exception. So now let's dry run the code. So for example, this is the linked list which is given to us. So head is not null, so this is not the case, right? We have initialized fast pointer which is here and slow pointer which is tortoise. Both we have initialized head node of the linked list. We are checking whether fast is null or not. Fast is not null and fast dot next is also not null. So every time fast is stepping 2 nodes ahead and slow is stepping 1 node ahead, right? So fast will reach node 5 and slow will reach node 3. That means this is the position. From here it is going to be here. So from this again we are checking whether fast is null or fast dot next is null. Again this is not the case. So fast pointer will reach at 21 and slow pointer will reach to its next node which is 5, right? Slow pointer will be at 5 and fast pointer will be at 21. Then again we are checking whether fast is not null and fast dot next is not null. Yes, both are not null. So that means again we are executing this line. So fast equal to fast dot next which is 81. So fast pointer reaches 81 and slow pointer reaches its next node which is 17. Again we are checking this condition. Fast is not null. Yes, fast is not null, but fast dot next is null. That means we are going to end it. So here we are going to return slow dot value which is 17. For example, we are having this case we are having odd number of nodes, right? For example, we are having even number of nodes. So till this point it is exactly same. So assume that there is one more node after 81. So till this point the steps are exactly same, where slow pointer reaches at 17 and fast pointer is at 81. So this is the case currently, and assume that there is one more node which is 90. So here again we are checking it. Is it fast not equal to null? Yes, fast not equal to null and fast dot next also not equal to null. So we have to execute fast equal to fast dot next means fast pointer is going to reach null. Then slow pointer will be at 21. So the same condition is going to work for both even and odd number of nodes in the linked list. So this case also we are going to return slow dot value which is 21. So now let's run the code for this. So after this we are going to print middle element of the linked list, right? So obj dot get middle and we are going to pass head node of the linked list. Let's run the code again and see. So in first case 17 is going to be the middle node and second case 21 is going to be the middle node, right? I hope this code is also helpful to you. Thank you for watching. Stay tuned. Happy learning.